Welcome back. So in this video, we are going to talk through an example problem that makes use of the ideal gas law. So the ideal gas law, PV equals nRT. We introduced that in the last video. So we said that when using the ideal gas law, that's when you've got one set of conditions for a gas. That pressure needs to be in atmospheres, the volume needs to be in liters, amount of gas must be moles, and temperature must be Kelvin. And for our ideal gas law problems, you will always use this constant 0.0821 liter atmosphere mole Kelvin when doing these calculations. So it's because of the units on R that we have to have our pressure, volume, and then our amount of gas and temperature be in these particular units. So let's start it. Let's try a problem. Let's say we have a gas that occupies a volume of 250 mils at 25 Celsius, has a pressure of 550 millimeters of mercury, and I want to know how many moles of gas are present. And so hopefully you realize already that before we start plugging in our pressure, volume, and temperature, we're going to have to do some conversions. So here's the problem. So before we start plugging in to values to PV equals nRT, we're going to have to convert some of these values. Specifically, we're going to have to take our volume and convert it to liters. We're going to have to take our pressure, which was given in millimeters of mercury, and convert it to atmospheres. So we convert it to atmospheres using that conversion factor. 760 millimeters of mercury is 1 atmosphere. Then we need to convert our temperature to Kelvin. So that gives us now, a volume that's in liters, a pressure that's in atmosphere, and a temperature that's in Kelvin. And that's what we need to appropriately solve PV equals nRT. But before we start plugging those in, let's go ahead and solve this equation for the variable we are looking for, which is N, moles of gas. And so hopefully you can see that to get N by itself, you have to divide both sides by RT, so that this equation, the ideal gas law, becomes N is equal to PV over RT. Now I can input my volume, pressure, and temperature along with the ideal gas law constant. And I can see that my units cancel appropriately. My 2 atmospheres cancel, my liters cancel, my Kelvin cancels, and I'm left with moles, which is good because that's the unit I'm looking for. And so doing the appropriate multiplication and division, that should give you 7.40 times 10 to the negative 3 moles. Okay. So that's an example problem of using the ideal gas law. In the next video, we're going to talk about how to use PV equals nRT to calculate certain physical properties of gases, mainly molar mass and density.